Hello everyone, welcome back to another video with Arduino. Today we're going to be looking at a game involving a runner and some obstacles and this endless scrolling effect. So we're going to be implementing our skills used in the previous video with the Arduino LCD, and then we're going to look at some cool things with the code. So let's dive right in. Alright, so the first thing I want you to know is the schematic. What's going on here is this is kind of a different arrangement. We have the potentiometer here, and the thing about the potentiometer is that, like I've discussed in my first LCD basics, is that it can control kind of like the resistance. So if we move this, it will change the display a little bit. These are all connected to the push button, and I'm going to be talking about implementing the push button as well as leaving the schematic on screen for you to look at. So now let's hop on the computer. Okay, so here's the schematic. It may seem very hectic and chaotic at first, but it's actually not that bad. I try to make them different colors so it's easier for you to see. Obviously, this is not the exact same thing that you see on my breadboard. I will show you what mine directly looks like after I show the schematic. So all I have to see is that this pink line, you can see that D7, D6, D5, and D4 right here. These are all connected to 6, 5, 4, and 3. Then if you go here, you see that E is connected to 9. And then for this one, RW, just going down these segments of the Arduino, of the LCD, you see that RW is connected to VSS. Then you can go down more. You see that RS is connected to pin 11. This wire is connected after RS is connected to the middle pin of the potentiometer. You come over here, you can see that this pin is connected to A, and then here are a few more wires. Don't forget this gray wire. This is VSS connected to K. And then this is what the potentiometer looks like. I don't know, this is the closest thing I could find on Walkme. When I was setting this up, I envisioned this as pin 1, pin 2, and pin 3. And I'll go more in depth. Obviously, this is connected to the breadboard, but like considering its size and how much more difficult it would make seeing everything, I don't think it was worth it. So here, remember, we have the push button that we press to make the sprite or the character jump. We have this one, these two at the end. We want to make sure that the first one or the second one goes to pin number 2, and the first one goes to ground. Here's a potentiometer. Oh yeah, and on the breadboard, everything is connected, so it looks a little bit different here, but these two wires, this one is connected to 5 volt, and this one is connected to the ground. I'll show you on the actual breadboard, but yeah, this is kind of just a breakdown of it. Feel free to pause, slow down. I can just highlight the wires for you if you want. Then it's not too difficult. All it is just a little bit, a few overlapping parts in this part. Let me just scroll in for you if you want to take a look at this. Then the button, obviously. So now let's see what the thing looks like on my breadboard, and then we'll hop right into the code. This is my schematic on the breadboard. If you want to, let me try to get a good angle for you to see. And you can see how all these wires, this first part shouldn't be too difficult because everything is seen on the schematic. But if you want to see this part, you can see how this one is connected to A. These are ground and 5 volt. And then this one is going a little bit crazy because some of the wires are not connected. I'll just recompile it. VO. And then obviously you have the push button here, and those are connected to ground and pin number 2. Okay, so take a quick look at that. Here is what the potentiometer on my breadboard looks like, and here's one just final look at everything. All right, so I have the code here. What you can do is just, I'll put it in the description. You could just copy it and put it into your IDE so that your project works, or you can listen along to me. I'm just going to dissect it part by part. So it's a lot of code, so we're just going to look through each of them and kind of evaluate each line. So let's hop into it. So the first part of this code is a lot of initialization, a lot of variables that we covered previously, but what I want to focus on more is this function called advanced terrain. What's really cool about it is it allows a scrolling effect, but it uses a different method than what we covered last time. So um, it takes in a it takes in a character and a byte as the parameters. We have a for loop which allows it to scroll this way. And then, so what happens is it uses a switch and case statement. So what is special about that is it's kind of like an if statement, but it's structured a little bit differently. So we're looking at the variable current. So if current is empty, so let's see this box, right? If this is empty, right? And this is the if statement. So if next is equal to solid, so if this one is equal to solid, which we see is true, then we're going to set it to sprite terrain solid right? Because there's a sprite terrain solid to the right. And if this is not true, right, for like, let's say this box, if we were evaluating this box, right, and we look to this side, well, there's nothing here. So obviously sprite terrain would be empty. So kind of how it works, right? So if this is true, then this would be the evaluation, else this would be true. And that makes sense. The same thing applies to this one. Let's say we're looking at this box, right? Let's say we're looking at this box. What happens is if the next is equal to empty, so if this is empty, let me draw that a little bit better. If that is empty, then we're just going to say there's solid to the left, because obviously there's a solid to the left of this. And then if there is, let's say it is colored in, then we're going to say that there's a sprite terrain solid, because this will eventually become the sprite terrain solid. And then, so when we get to the second part of the evaluation, where if this becomes solid, there's a solid to the right. So let's go back to this example right here, where there's a solid to the right, and we evaluated that in the first switch statement. What happens is this becomes solid, right? If you're scrolling this way, eventually what's going to happen is this one's going to become solid. Then this one is going to become solid. And then this one is going to become empty, right? Because you're moving this way. Same thing applies for the left. Okay, so here's the code for the second part. This is a different function which involves drawing the hero. So this is the animation involving the character going this way, jumping, running on the top layer, and also falling down. So this is just basically, I'm just going to go through the cases. There's a lot of positions here that were defined at the start. So I'm just going to give kind of like a brief overview of everything. So you can see here, this is starting a jump, halfway up a jump. So you guys can definitely check this out if you want to. But what's going on basically here is we have different cases. Let's say that right here, this is hero position off. So let's say if like the hero position, let's take one of the cases. So we have hero position run lower 1. Hero position run 1. So this is just saying that hero is running on the lower row, right? So there's obviously one position for every step in the game. So here's the first thing, hero position 1. So this is the case, upper. Okay, so we're gonna set that to sprite terrain empty. So he is not going to be, or the character is not going to be in this area. He is only going to be running. So basically, it's just creating the animation, right? If he's on the lower row, he shouldn't be on the top row, and it should be empty of the sprite. We take other examples. We have jump 2, jump 7. Let's just take a quick look at that. Jump 2 and jump 7. So this is just halfway up jump. So it's just creating these different animations for the character to complete his jump, right? So you're just going to go through a series of movement, right? Because when you're when you're playing the game, right, the sprite doesn't just jump up like this, right? He kind of has the sprite has some direction. So when you jump, right, he's jumping like this. Then if he's running straight, he runs straight like this. And then if the character is jumping, he kind of falls down like this way. So it's not immediately just vertical jump. So that's what these cases are talking about. The animations behind um, each of the when you're controlling the sprite. And now we're going to get to this bottom part, which is an if statement, but it's pretty crucial for the game to continue. So if upper, the variable we defined here, is not a space character, the value of terrain upper at the position of the hero is set to upper. Then a collision, you check the collision here. So if collide, so if upper save equals up terrain empty, let me pull it up here. So if he's running and here collide, let's just say here, if he's running and he jumps up and they detect that these two are in the same box, they're equal to one another, then we set that to true. So the player has collided and the game is over. Same thing happens for lower. We see here is if there's an empty space, if there's a space, it sets that to lower. If it collides, once again, let's say there's a box here, right? If it collides, these two become in the same position, we set collide to true and the game is over, just like for the first part. A lot of this is basically just the same information. This is talking about the positioning and the area where the score is shown. I have set cursor, print the score, and then a lot of this is just using arrays and seeing if the collision is true, and then with a few more additions of some animation. So now let's just look at one quick thing, because this video is getting pretty long, and there's not much, any really interesting stuff besides that, in the code. So this is what we were talking about before. This is the setup, like we've been looking at. So you're just setting up the pin mode, the digital write. We enter the loop. Oh yeah, we saw this, the begin and initialize graphics. There's a 16:2. So what happens here is this is the loop that the hero goes into, so that it's possible to update the game for the terrain, and it's possible to update the position of the sprite. So what we see here is if not playing. So if the game is already over, obviously you just want to end the game. So that's what happens when you press game over. So if this value will be passed in, right? And it will be constantly updated. So if you're not playing, then the game is over, right? Here's the blinking effect that I'll display on screen right now. Here is just the advanced terrain. This is what we were looking at before. This was the method, and here is an example of a method with these parameters. So what it's doing is it's passing in values that the computer can enter in and go through the process, like we were talking about in the first part with the advanced terrain method. You could definitely look more into this if you're interested. Let's see what else we have here. We have the new terrain. We want to make sure that it's being constantly updated, and that here's the random to make sure that the new terrain, like to the right, to the left, is always there's new different obstacles. It's not the same thing over and over again. That's something you definitely want to make sure, or else the game starts to get boring, right? Who wants the same obstacles to appear over and over again? And then these are just the animations, and we increase the distance, and these are kind of correlated to the points. Here's another if statement. Playing is false, there's a collision, and we delay 100. So basically that's kind of just the whole gist of it. This is really interesting. You look into each of these different methods, they create different animations, and this is kind of like, it looks simple, but like looking at how much code is in this, you really are just, it's really interesting how much you can do with programming. So here's kind of everything. We were introduced to case, switch, and break statements. And quick note, you need to include this exact syntax. You can't just have a switch case and then forget the break, because the break is important for evaluating which cases you're talking about. So this is one case, this is two cases, this is three cases. Here was the animation. And so, yeah, that's kind of the code for this. So that's it for this video. I really hope you enjoyed learning about this Arduino LCD game. It looks simple, but there's actually a whole lot of explanations and cool, interesting things about it. So it's really cool. You can also see the foot animation and the actual person. So after playing this, my highest score was 50, which is not very good. If you guys do make this, tell me what your high score is. And if you really did enjoy and you learned something, definitely don't forget to like and subscribe. And we're going to be implementing this